Hey, what's up? How you doing this amazing Saturday evening? Last session of solubility. Oh, last session of ionic equilibrium. Session number 6, lecture 6. We're going to talk all about solubility today. मेरी आवाज साफ आ रही है? Can you see me, hear me? Yeah, those are the standard questions. Let's get them out of the way. All good? What's up? How you doing? So you said there's a scary looking equation on my right over here. And as always, I'm going to tell you how to solve questions without using these equations. Yeah, from first principles, as always. So there was a homework question, and I did something funny. I gave you two questions, and out of which one I solved in class. So I'm just going to look at one of the homework questions that we looked at, which both Mayuk and Poonam answered. I'll start with that. But where do you think this solubility business is useful? Do you remember salt analysis? Is it there in the syllabus of NEET? Well, that's a gray area, right? Salt analysis directly kabhi kabhi hai, nahi hai. But if you look at maybe P block elements, right, that has anion analysis, and with the use of this whole solubility business, you can look at cation analysis as well. Do you guys have it in lab? Well, let me know in the comments. Anyway, what's happening? So let's look at the first question that I did for you guys. Hold on, let me just gonna quickly check अगर ये stream चल रही है कि नहीं चल रही है. Yes, stream चल रही है. Okay, great. All right, straight. So, because that happened last time, right? मैंने on किया था, no one's able to hear me. Okay, this was a question, right? Which of the following is not a buffer solution? And both Poonam and Mayuk said the answer was D according to them, right? Now, do you guys agree with them? What do you think? What is a buffer solution? Well, buffer is something that has this and this in solution, or this and its salt, right? Both of this in solution, which is these are salts and these are the weak acid slash base. इसकी theory हम लोगों ने डिटेल में की थी last session में, okay? कि what's the scene with acid bases and all of that and how buffers are formed. Now in all of these, you can clearly see that देखो, this is HS minus and H2S. So this is the weak acid and this is the salt of its conjugate base. तो ये वाला तो definitely buffer बनेगा. What about this? This whole thing right here, this one is yeah, this is the base, right? And this one is the salt. Okay, so ये भी looks like is going to be this thing. Hey, good evening. What's up? What's up? Hey, Vishal, Poonam, what's up? D is what Vishal is saying. I agree with Vishal. But we'll walk through the option anyway. Good job, Poonam, on getting this answer right as well. So, and ये वाला कौन सा है? This is a weak acid and this is the salt of its conjugate base. You can look it up, yeah? इन दोनों में फर्क सिर्फ एक H plus ion का है, and that's when you know that, oh, there's a conjugate acid base pair, etc., etc. Here, this one is a very strong acid, very, very strong acid. When you learn periodic table, I'm sorry, when you learn P block, you will see that ClO4 minus ions very readily give away H plus, and this is a very strong acid. KClO4 is a salt of this, sure, but it doesn't work. This is a strong acid, so hence is your odd person out, and this is the answer. What's up, Ashutosh? How are you doing? Good evening, Poonam. If I didn't already say that. So what's solubility? आपको थोड़ा सा idea है, right? If someone asks you कि what is the solubility of NaCl in water, you will say कि अच्छा अगर मैं पानी में NaCl डालता जाऊं और जब तक वो सैचुरेट ना हो जाए उस अमाउंट को हम लोग बोलेंगे सॉल्युबिलिटी. मतलब कि इफ आई कैन पुट से 15 grams of or say 30 or 40 grams of NaCl in 100 ml of water or 1 liter of water at this temperature. So there are three things. एक चीज है the amount of substance that can be dissolved. Second is the volume of the solvent that you dissolve it in, and the third thing is temperature. इन सब चीजों को हम लोग एक टर्म से बात कर सकते हैं. We can talk about just S, which is solubility in mole per liter. ठीक है. And temperature, we'll take it as room temperature for all of our conversations, etc. So that's a general idea of what solubility is. But we're going to talk about sparingly soluble salts. मतलब कि कुछ salts जो हम लोग पानी में डालें वो ठीक से dissolve ना हो. And that's our focus right now. Okay. What's up? Yeah, I know Vishal. 2 दिन पहले, yeah. बहुत अच्छा याद है आपको. But अभी तो सब साफ सुनाई दे रहा है ना. Hey, what's up? Deepanvita, how are you doing? Yeah. So the maximum amount that can be dissolved, and solubility general idea है, ठीक है, but we are going to talk specifically about sparingly soluble salts because that is what we can now figure out using the whole ideas of ionic equilibrium जो हमने डिटेल में अभी तक किए हैं. ठीक है, ठीक है. The goal is to get to a saturated solution. मतलब saturated मतलब मैं उसमें थोड़ा सा भी और salt ऐड करूं, immediately it will precipitate out. Okay, cool. So here is the NaCl category. मतलब solubility काफी ज्यादा है, 0.1 मोल से ज्यादा. slightly soluble and sparingly soluble are just ये सब definitions है, etc. etc. ठीक है? All right, cool. So NaCl and water is one example. I gave you that. Slightly soluble BaOH whole twice and AgCl भाई ये तो almost soluble नहीं है, practically नहीं है. हम लोग we're going to look at the last one is going to be our focus. ठीक है? So there is an equilibrium established, as you may have guessed, between the ions in solution and the undissolved solid. Undissolved solid मतलब undissolved salt specifically. So अगर AgCl देखो, so this is what you write down, that this is a solid and this forms Ag plus Aq and Cl minus Aq. Am I covering this? I am covering this. Okay, cool. Anyway, yeah, you can check this out. Check this out of the notes. Okay, so this is the expression for it, and notice that I have written solid यानी कि S here and not AQ यानी कि aqueous. If I were to write NaCl, मैं लिखता यहाँ पे भी AQ and I would write here as well, you know, oops, hold on. I will not, यहाँ पे NaCl तो solid होता, I would not put a double headed arrow. I would just say कि भाई ये पानी में डालो तो ये बन जाता है ये, ठीक है? मतलब all of it basically just dissolves. खैर, anyway, I need to put water on top of this, तभी पानी से hydrate होगा, etc. etc. Anyway, so you take another one BaSO4 and you would write it like this. Okay, so I need to add water on top and I get this expression. All good here, yeah? I mean just setting up some basics. So now the equilibrium constant for this expression. Why equilibrium constant? क्योंकि ये इस जो है, this is going to be very very small. These values are going to be extremely small. ये Ba2 plus ions की concentration SO4 2 minus की. So we can set up an equilibrium that looks like this. Okay. So the square brackets, whoops, the square brackets as usual give you the concentration terms. Yeah, this fell down. And SO4 2 minus and Ba2 plus. This is a 1:1 mole ratio. We'll talk about other ones as well. तो ये constant है, we can remove it. We're going to just take it as 1 because this is solid. Remember, solid and liquid को हम लोग consider नहीं करते हैं. So ये equilibrium constant for dissociation of BaSO4 is this. And theoretically, this is known as a solubility product. Now, this is where things start to get interesting. Okay. Look at this. Experimentally, ये value है. NCERT में एक बड़ी सी table दी हुई on the right hand side in a yellow background of all the KSP values of a lot of salts. So on one of those salts is BaSO4 और इसकी KSP value काफी low है. अगर KSP value ये है, then you can backtrack and get कि अच्छा इसकी solubility कितनी होनी चाहिए. And we'll do that in due time. We'll do that. But what is KSP? It is a product of molar concentration of ions in the saturated solution raised to the power equal to the coefficient of the ion. मतलब हम लोग equilibrium का ही setup कर रहे हैं, right? And we're just calling that equilibrium constant a special name, which is solubility product. Okay, KSP. ठीक है? This is what we're talking about right now. There's another idea called the ionic product, which we'll talk about in just a bit. But as I told you, this only depends on temperature for a particular salt. So, अगर हम लोग that was for a 1:1 mole ratio thing, right? What if I take some random salt MX XY? This is a funny thing, right? The reason why I've written it like this because NCERT में I would not write it MXXY. That's confusing. I would use M and N, but खैर छोड़ो, whatever, right? So this would furnish X moles of M and Y moles of X. Okay, and there are powers, etc., etc. मतलब that shows you कि कितना charged ions है. Now I will say that the solubility of this is still going to be S. Okay, मतलब कि I start off with S 0 and 0. Okay, initially, let's say initially or at time equal to 0. ठीक है, मैंने लिया S moles of MXXY, तो उसको मैं पानी में डालता हूं तो इतने आयन बनेंगे जो भी बनेंगे, बट मेन आइडिया है कि आई वांट टू नो कितना मैं डिसॉल्व कर सकता हूं, एंड दैट इज व्हाट इज गिवन बाय दिस S. ठीक है, कूल. डू यू हैव टू रिमेंबर द वैल्यूज? नहीं भाई विशाल, एब्सोल्युटली नॉट, बिल्कुल भी नहीं. अरे मैं तो तुमको बोल रहा हूं फॉर्मूला याद नहीं करने को वैल्यू क्यों याद करनी पड़ेगी. खैर, ये सब यहाँ पे डिटेल्स दी हुई हैं. इफ यू डोंट अंडरस्टैंड दिस, टेल मी. दिस इज जस्ट सेइंग कि देखो, इफ आई हैव से अ सब्सटेंस लाइक AlOH whole thrice, then this will form one Al3 plus ion and 3 OH minus ion, hypothetically speaking. ठीक है, ये अगर आप एक्सप्रेशन यहाँ पे डालोगे तो ये मिल जाएगा. Anyway, so now if you do this, then things become interesting, right? Because there are X of MP plus ions, you got to raise MP plus का concentration to the power X. थोड़ा confusing लग रहा है. Don't worry, when you do numerical, it will be straightforward. Similarly, the anion is raised to the power Y. And then you get this amazing expression जो है इस thumbnail में, जो है थोड़ा डरावना, but this is the final expression for S. Don't worry, I'll teach you how to do this out in all the expressions. ठीक है, हम लोग जो है directly first principle सब करेंगे, बट यही एक्सप्रेशन एनसीईआरटी में है जो मैंने क्विकली डिराइव किया है. आई पर्सनली एम नॉट अ फैन ऑफ दीज डेरिवेशंस, बट इट्स ओके. ठीक है, हमने कर लिया है. इट्स गुड टू नो, बट डेफिनेटली मग करने की जरूरत नहीं है. इट्स गुड टू नो कि हाउ दिस हैपेंड, बट वील डू इट फॉर एन एक्चुअल कंपाउंड एंड फिगर इट आउट. देखो, फॉर एग्जांपल, राइट, CaF2. नाउ कैल्शियम फ्लोराइड फॉर्म्स one calcium atom, one calcium ion and two fluorine ions. ठीक है. Now इसका मैं KSP कैसे लिखूंगा? देखो, now at equilibrium I will say कि there is, इसको तो कंसिडर नहीं करेंगे. We will say there is S and there is 2S of this, right? And then guess what happens? S तो as it is रहेगा to the power 1. 2S will get squared. क्यों? क्योंकि इसके कोएफिशिएंट है 2. Do you follow this? ये मैंने क्या लिखा है यहाँ पे? Is this okay? Yeah, numerical wall. Exactly, Vishal, you're absolutely right. I agree with you. Do you follow what I did over here? मैंने यहाँ क्यों ऐसे expression बनाया है? Right? First idea is the mole ratios. CaF2 से बनेगा एक calcium ion, दो fluoride ion. Hence S and 2S. Then मैंने कुछ powers लिखी हैं. I will omit the powers over here. Let me write it where it belongs, which is KSP में ही. Right? यहाँ पे मैंने equilibrium का ही idea लिया है. Chemical equilibrium, straightforward stuff. Right? If you have A, B, B, etc., giving you C, C, and D, D, then you say that equilibrium constant is simply this. यही चीज मैंने यहाँ लिखी है, कुछ नई चीज नहीं लिखी है. ठीक है, मैं फिर से आपके लिए लिख रहा हूं ताकि अगर गलती से भी कोई कंफ्यूजन हो, that goes away once you see this. ठीक है, this is the equilibrium constant का expression, and मैंने वही चीज यहाँ पे लिखी है. Cool, that's it. That's it. So this is just a concentration of F minus ions, and this is the concentration of Ca2 plus ions. तो मैंने F minus स्क्वायर किया, Ca को ही किया. So now this is it. This is 80% of the battle won. ये निकल गया, मतलब you get 4s cube to be equal to KSP. And this is just with this idea you should be able to solve any question on solubility. ठीक है, चलो एक और लेते हैं. AlOH3 का भी एग्जांपल मैंने दिया था. That's also here. Now this will form one aluminium ion, 3 plus ion, and 3 OH minus ions. How is this different from the last time? The only thing that's different is यहाँ पे S होगा, यहाँ पे 3s हो जाएगा. This is the concentration of Al3 plus. This is the concentration of OH minus ions. Hence, and again, this is obviously at equilibrium. So KSP क्या होगा? Now it will be S times 3s cubed. तो यहाँ पे नंबर आएगा funky. It will be 27s power 4, which is KSP की value. That's it. ठीक है? Any doubts, guys? Please ask me अगर इस चीज में कोई doubt है. This forms the basis of everything we are going to do. So I've taken 2, and this is the third example. Yeah, quality over quantity. इसके बाद हम लोग एक और करेंगे क्या? नहीं, I think this is the last example we'll do. Ca3PO4 whole twice. Okay. यहाँ पे हमको बनता है इसे 3Ca2 plus ions, 2PO4 3 minus ions. तो इससे हम लोग लिख सकते हैं 3s and 2s, right? So now you're going to do 3s cubed times 2s square. तो यहाँ पे मिला आपको 27 into 4 s power 5. What you have to cross check is, देखो, जो total number of ions है, number of ions, that should be equal to the power of s. Okay, ये बहुत जरूरी है. Power of s यानी कि इस expression में. Which expression? In this nice expression over here. This is a cross checking thing. Numbers में students काफी बार गड़बड़ी कर देते हैं. Numbers में ध्यान से करने वाला एक ही step है. Make sure that you write this step down. At equilibrium कितने बनते हैं? ठीक है? Okay? All right? Great. Excellent. चलो एक सवाल लेते हैं. pH of a saturated solution of BaOH whole twice, barium hydroxide, is 12. The value of solubility product of BaOH whole twice is which one of these? सोचिए, ट्राई करिए. यहां मैंने pH बताया है. अब pH कहां से आया इस केस में? See, in this case, in the solution, you have barium ions and hydroxide ions. तो हाइड्रोक्साइड आयन कॉन्सेंट्रेशन से हम लोग को इनडायरेक्टली पता चल जाता है कि डायरेक्टली पता चल जाता है कि पीएच क्या है, राइट? ठीक है, ट्राई करके देखो. पूनम इज सेइंग सी. ओके, ग्रेट. ये एक्चुअली इनफैक्ट आया था एआईपीएमटी 2012 और 2010 में भी 2 बार आ चुका है ये. इनफैक्ट इसका नेक्स्ट सवाल इज जस्ट इसी टाइप की ही चीज, बट थोड़ा सा मियांडर करके, थोड़ा बदल के. सो इट लुक्स लाइक 3-4 साल में एक बार सॉल्युबिलिटी पे सवाल आता है. That's what it looks like, right? I'll show you. 2017 में भी सवाल था. विशाल is saying B. Okay, great. पूनम is saying C. ठीक है, देखते हैं. So अगर pH is equal to 12, यानी कि POH is equal to 14 minus 12, यानी कि 2. ठीक है. So from POH, now I've got OH minus ion concentration. OH minus ion concentration is simply going to be 10 power minus 2. Why do I need this? Look at this expression. BaOH whole twice will give me Ba2 plus ions and hydroxide ions. Now, look at this. मैंने वो S और 2S वाला सेम चीज की at equilibrium and मैंने इसको अलग कलर में लिखा है. I'll tell you why. Now, KSP expression is going to be S into 2S whole square, right? Just from this equilibrium वाला concept. But what do I need to know? मुझे KSP ही निकालना है. देखो अब आया ऊंट पहाड़ के नीचे. नाउ आई नीड टू यूज दिस आइडिया. ठीक है, वही माइनस लॉग ऑफ 2s इज इक्वल टू 2. सो 2s इक्वल टू 10 पावर माइनस 2. क्यों? यही तो है OH माइनस आयन कॉन्सेंट्रेशन. दिस इज OH माइनस आयन कॉन्सेंट्रेशन. पूनम, नो प्रॉब्लम, एक्सीलेंट वर्क ऑन फिगरिंग इट आउट. यही तो जरूरी चीज है. एक बार जल्दी में कुछ दूसरा आंसर मिल गया, बट यू हैव टू चेक योर आंसर, एंड इफ यू आर डूइंग दैट, ग्रेट जॉब, बहुत अच्छी बात है. ठीक है, सो 2s इक्वल टू 10 पावर माइनस 2 होगा. तो यहां से तो फिर डायरेक्ट है, राइट? यू डू 10 पावर माइनस 2 होल स्क्वायर एंड 10 पावर माइनस 2 डिवाइडेड बाय 2, क्योंकि यहां पे है s, which is simply going to be equal to 10 power minus 2 divided by 2. That's it. ठीक है, सो इसको अगर देखो तो बन गया 10 power minus 6 divided by 2. 10 power minus 6 divided by 2 will be this option right here. Good job अभिनंदन, good job. ठीक है, थोड़ा सा इंटरेस्टिंग सवाल था ये, थोड़ा सा काफी इंटरेस्टिंग है, थोड़ा सा. And look at this, a similar question being tested in NEET 2017. Similar question क्यों बोल रहा हूं? You'll know right away. Concentration of Ag plus ions in saturated solution of Ag2C2O4. ये similar है और थोड़ा सा अलग भी है. Similar in the way that देखो previous question में था, you had a cation, let's say AB2. इस केस में A2B है, right? That's what this is, or A dash B dash, जो भी बोलना चाहो, right? Because it's Ag2 and then oxalate ion, जो भी बोलना चाहो. ठीक है, solubility product इसका निकालना है. In fact, तो I think ये काफी similar होगा to last time. Try करो. यहां पे आपको S directly दे दिया गया है. This is the value of S. What do you think? It's okay, Poonam, don't worry about it. Great job. Good job in figuring that one out. इसमें क्या करोगे? What do you think the answer is going to be for this? You want to take some time to figure it out? Try करो. So the amazing thing about this is कि NCERT के सवाल actually काफी अच्छे हैं, especially in terms of solubility. You should definitely practice them. In fact, further down this session, I have one question from NCERT जो काफी सही लगा मुझे, which I have solved. So if you're solving NCERT questions for NEET, especially for solubility, yeah, I think that's worth it. खैर, Vishal is saying C on this one. Okay, let's go ahead and solve this. Same चीज मैंने यहाँ पे लिखी है, equilibrium का expression रखा है, and as you'll see, it's very similar to the last question. Yeah, absolutely, because देखो, in the previous question it was this, in this question you have this. Yeah, this is previous question. Okay, cool. So 2s times s. Okay, so KSP is simply 2s whole square times s. अब यहाँ पे हमको दिया हुआ है कि 2s is equal to this value right here. Okay, 2s. Now this is the small thing you have to be careful about. Okay, काफी बार I have seen students say कि यार this is s. Think about it. अभी थोड़ा basics पे जाते हैं हम लोग. Why have I written this to be 2s and not s? Because s is the solubility of the salt. ठीक है? When you say s, that's the solubility of the salt. Ions की solubility हम लोग बात उससे derive करते हैं. Think about it, right? अगर मुझे पानी में डालना है कोई salt, तो I need to know कितना ग्राम वो लेना है. How will I find out कि यार Ag plus ions के क्या मास होगा, वो किसको भगवान जाने यार. How do you do that? That is harder to do, practically speaking. So practically speaking, it would make a lot more sense for when we talk about, चलो इसका मास अगर मैं ले लूं 0.2 ग्राम, that is solubility, right? So or whatever, moles per liter, जो भी करना चाहो, जिस भी term है. But my main point is S is the solubility of the salt. Okay? ठीक है? इसीलिए what we're talking about here, 2s is this right here. ठीक है? Hence I've said that 2s is equal to this. क्यों मैंने लिखा है, ये मैं आपको थोड़ा क्लियर बन जाता. इसके बाद तो स्ट्रेट फॉरवर्ड है. You do the same thing, 2s whole square, which is this value square, and into the same thing divided by 2. Numerically, it turns out the concept is very similar to what we did in the AIMS AIPMT 2010 and 2012 वाला question. And then उसके बाद you get it. C. Yes, Poonam, Deepanvita, excellent work. Yes, C is the right answer. Yeah, Abhinandan तो आता रहता है. Abhinandan is around. He's a frequent of this channel. I've seen him around as well. Good job. This should be the answer. How do you get to this? देखो यार, I'll tell you the quick way of doing this, right? 1.1 cube times 2 square. 1.1 क्यूब क्या होता है? 1331. अगर ये याद भी नहीं है तो इट्स ओके. 121 into 11 कर लो, ठीक है? तो this thing into 4 is approximately 5.2, right? 5.2 और या फिर 5.3 ले लो, तो 5.2 के आसपास ही है. This is the answer, ठीक है? और पावर 10 पावर 12 है. The thing is, the reason why इतना मैथ्स करना पड़ा, देखो 10 पावर -12 में दो ऑप्शन है, ओके, ए एंड सी, तो इसलिए you have to do a little bit of this business over here. चलो, excellent work everybody. Let's move on to the next idea. Now, I want to talk about the ionic product. I have defined to you, I've defined very, in a mathematical way and the theoretical idea कि KSP का क्या मतलब होता है, solubility product. Now, let's talk about ionic product. Ionic product is, let me draw a, similarity between, say, Q and K and KSP and IP. जैसे equilibrium constant is similar to KSP, Q reaction quotient is similar to KIP, यानी कि ionic product. ठीक है? That's it. It's as simple as that. So ionic product is the product of molar concentrations of ions raised to stoichiometric coefficients and कभी भी at any point in time. ठीक है? ये KSP है. अच्छा, नेक्स्ट वाला स्लाइड था. I thought we were on the next slide. ठीक है, cool. Anyway, KSP तो तुमको मालूम है. KIP, as I was talking about, ionic product is कोई भी at any. This is equivalent to Q or reaction quotient. KSP is equivalent to K. ठीक है? So you're still doing the same thing. You're raising to stoichiometric coefficient. वो सब कहानी हम लोग कर रहे हैं. We're not stopping that. But this is at any concentration, not necessarily at saturation, above saturation, below saturation, etc., etc. So, and KSP is only at saturated products, saturated compounds, solutions, and KIP कभी भी हो सकता है. I'm great, Vikas. How are you doing? JEE main के भी करवाएं, Vishal? Okay, sure, man. My only concern is time, and since I'm the only person teaching right now on this channel, hopefully we'll get more people soon. Yeah, counting on that. We'll try and ramp that up. My focus right now is to try and finish the syllabus as much as possible. जितना हम लोग जल्दी कर सकते हैं, we'll do that, and we'll do that. Those things maybe we'll do closer to the NEET exam, right? JEE main and extra questions, etc., etc. Here, this measures the actual amount, and this measures the maximum amount of ions. KSP maximum मतलब just precipitate होने से पहले. So, 3 cases. अगर KIP, ionic product, is less than KSP, मतलब I can add a little bit more salt without being saturated. ठीक है? मतलब more salt can dissolve, no precipitate forms. If it is equal, then it says कि एक छोटा सा भी मैंने, if I add a little bit of salt, then yes, precipitation happens. Okay? This is saturated now, थोड़ा सा भी ऐड करना चाहिए. अगर KIP is greater than KSP, then definitely it will precipitate out. Whatever extra add will precipitate out. ठीक है? This is just theoretical. इन चीजों के ऊपर सवाल I don't think NEET will test, but just theory wise we should know. चलो, let's look at this interesting question now. What will the solubility be of AgCl when you add 0.1 molar of NaCl to it? Okay, KSP की वैल्यू यहाँ पे दी गई है. This is very interesting. What do you think happens here? The thing to note, as usual, what do you have to do? KIP निकालो पहले. But there's one more thing over here. KIP निकालो. अगर KIP is greater than KSP, then precipitate हो जाएगा. अगर it's equal, then no precipitate. अगर वो कम होगा तो unsaturated हो जाएगा. ठीक है? That's the condition. So now I want to talk about using that example of NaCl and the solubility of AgCl in some amount of NaCl itself, the effect of common ion on the solubility of sparingly soluble salts. Common ion? Yes, chloride ion वहां पे common था. So in this case, if I add a common ion, then solubility कम हो जाएगी. ठीक है? That's it. It's as simple as that. But we can put some math around this. So the first thing to notice is कि AgCl की solubility will be lower in a solution of NaCl as compared to a solution of just water. क्यों? क्योंकि common ion है, and that will suppress the dissociation of AgCl in that aqueous solution. ठीक है? Cool? जरूर विकास. अगर कोई चीज आपको नहीं समझ में आ रही है बताइए. I'll explain it again in Hindi right away. ठीक है? देखो, as soon as I add NaCl, वो जो क्लोराइड आयन्स हैं, they are like कि bro, हम तो ऑलरेडी यहाँ पे हैं. And this reaction goes backwards. Le Chatelier's principle. यही चीज, ये पूरा एनिमेशन आपको दिखा रहा है. खैर, let's look at the math behind this. Okay. Now, before addition of NaCl मैंने नहीं ऐड किया. उससे पहले, this is the good old solubility product. Simple 1:1 S square होगा इसका KSP, and you can get that value of S to be the root of KSP. That's it. जैसे ही मैंने ऐड किया NaCl, look at this. I have increased the concentration of Cl minus ions by 0.1 molar. And you'll notice 0.1 molar is a huge concentration, right? Because KSP values हम लोग देख रहे थे were to the tune of 10 power minus 12, 10 power minus 8. यानी कि S will be 10 power minus 4, 10 power minus 6. मतलब काफी छोटा है S की वैल्यू. मतलब by adding this, I have, disturbed the whole equilibrium by quite a bit. देखो, so now two of them are in solution. दोनों चीजें, 1 and 2, AgCl and NaCl. इसकी solubility हो गई S, इसकी हो गई S plus 0.1. But because S is so much smaller than 0.1, ये practically हम लोग बोल सकते हैं कि this is simply going to be equal to 0.1. So NaCl अगर मैंने बढ़ाया तो solubility of AgCl हो गई कम. You want me to show you the math? I'll do that right away. Okay, but just clearly फिर से बोल रहा हूँ कि Ag plus needs to decrease or AgCl needs to precipitate out of the solution to keep KSP constant. That's a disturbance, Le Chatelier's principle and all that, right? देखो, so KSP is equal to S into S plus 1, which is simply going to be equal to 0.1 because 0.1 is much greater than S. तीसरे वाले की जरूरत नहीं थी, but ठीक है, cool. So now देखो, अगर theoretically if it's the order of 10 power minus 10, then S is going to be of the order of 10 power minus 9 as compared to 10 power minus 5, right? अगर उसमें जो है मैंने अगर क्लोराइड आयन नहीं रहा होता, अगर मैं हाइपोथेटिक एग्जांपल दे रहा हूं, लुक एट दैट, 10,000 गुना कम हो गया. So there you go. And this neat trick is used in cation analysis, in salt analysis. ठीक है, वो होता है first group, second group, third group, fourth group. There is some amount of H2S added one place, NH4 हो जो added, वो सब है क्या? By the way, dude, एक चीज बताइए, have you done all of this in the lab, in the chemistry lab? ये सब चीजें आपने की है, salt analysis? Let me know. This is going to be very useful there. खैर, वहीं पे नेक्स्ट पेज पे वही हम लोगों ने कैलकुलेशन किया कि KSP happens to be in the tune of 10 power minus 10 and 0.1 हटाओ तो देखो S कितना कम हो गया, solubility कितना कम हो गया. ठीक है, cool. Little bit more theory and then we'll do a couple of questions. Let's talk about simultaneous solubility. यानी कि I've got multiple compounds in the mixture. ठीक है, and I try to precipitate them out one by one. तो पहला कौन सा precipitate करेगा? इस टाइप के सवाल NCERT में काफी हैं. And in fact, not just that, right? Usually, when you have solutions, like say, if I have AgCl, I could have AgBr and AgI in the solution. Okay? And I want to selectively take out some of these compounds, keep the others in the mixture, separation techniques, etc., etc. Metallurgy, this is useful. How do you do that? Okay? How do you do the math? That's what we're going to talk about. So let's focus. Let's build up from the basics. If you have two sparingly soluble salts, just talk about two. दोनों मैंने पानी में ऐड किए. There will be simultaneous equilibria of both of these. Okay, simultaneous मतलब कि we'll talk about it. Quickly we'll talk about it. Okay, because of the simultaneous equilibria, जो solubility of दोनों salts will be lower than what its individual solubility क्योंकि of this common ion coming from the other salt. बहुत complicated हो गया. Example देता हूँ, मैंने लिख के बताया था. देखो AgCl है और AgBr है. ये दोनों मैंने डाले पानी में. ठीक है? Okay, so I am going to say that iski value is going to be KSP1, this is going to be KSP2. When I put both of these in solution, look, there is a common ion which pushes back both of these reactions. Okay, it pushes back both of these reactions. है ना? तो इसका हो गया, if I say this one is 1 and this one is 2, then this is going to be sum of both together. If you're wondering how conveniently मैंने लिख दिया है, this is going to be 1 plus 2, because देखो, this concept of 1 or 2, nature doesn't care. मैंने पानी में दोनों चीज डाली है, so both will coexist. Okay, and this is the beauty when you have more than one. When you do any common ion questions, this sort of a mathematical equation always be set up. अगर वो common ion है, तो उसकी concentration will be same in both the equations. It has to be. It has to be. Okay, be careful about things like this. Care. In reality, what will happen is that one of the reactions will get reversed, etc., etc. I'll give you an example of that in some time. But for now, S1 is solubility of AgCl, S2 solubility of AgBr. S1 is the solubility of this salt and S2 is solubility of this salt. Remember, S यानी कि solubility is always of the salt itself. And उसका result is कि ions की solubility की हम लोग बात करते हैं in terms of S1, S2 और जो भी है. Cool. चलो. Here's the question. Solubility product of BaSO4 and BaCrO4 are given to be these values. काफी पास में, look at them, pretty close to each other. Calculate the simultaneous solubilities of BaSO4 and BaCrO4. यानी मैंने पानी में दोनों डाल दिया, अब दोनों की solubility हो जाने वाली है कम. कैसे? Let's set up that equation that we just did. Interestingly, इसकी भी stoichiometry is going to be very similar to what we just saw in the theoretical idea, which is BaSO4 gives me Ba2 plus and SO2 minus. Yeah, मैंने already इसका S1 plus S2 लिख दिया because I know what's going to come next, right? This is say S1, this is S2, right? This is reaction 1, this is reaction 2. और दोनों पानी में साथ में हैं. अब इसका क्या किया जाए? इक्वेशन आएगी. इक्वेशन हम लोग याद नहीं करेंगे, हम लोग करेंगे फर्स्ट प्रिंसिपल से. फर्स्ट प्रिंसिपल से क्या है? देखो, लेट्स डिवाइड बोथ ऑफ दीस, राइट? फ्रॉम दिस आई गेट दैट KSP1 is going to be equal to S1 plus S2 into S1, and KSP2 is going to be equal to S1 plus S2 into S2, right? Now look at this. This is one of those amazing mathematical equations कि I have two variables and two equations, and if I just divide both of these, देखो S1 plus S2 gets cancelled out, right? So what I have is a ratio of S1 and S2. See, मुझे मिल गया ratio of S1 plus S2, है ना? That's it. And my life is sorted. I'm like, बहुत chill अभी. So S2 is going to be equal to 2.4 S1, and then you get that 3.4 S1 square is equal to this value. So look, I've already proved to you कि S1 की solubility कम हो गई है, right? S1 initially without any other thing was 1 into 10 power minus 10. इसका root हो जाता, right? Now the new S1 dash or whatever solubility because of these two is going to be this value, the original solubility divided by this. ठीक है? So S1 divided by this. Let me write the original solubility so that इसको समझ में आए. Original solubility. I know मेरे पीछे आ रहा है, but you'll be able to figure this out. Any doubts, guys? Hey Ayush, what's up? Any doubts so far? How this works? Sure, I can also give you a scary equation which I'll give you in a minute. How to, इसको कैसे लिखें, etc., etc. But did you follow what we did from first principles? And I proved to you that देखो, इसकी वजह से हम इसकी जो solubility कम हो गई है by a factor of root 3.4, which is about 2 times, right? Approximately 2 times थोड़ा कम, 1.5 गुना. Let's say 1.5 times. 1.5 square is 2.25. So 1.7 times, I think. 1.7, 1.8 times. 1.8 is 3.64. So 1.7 time बोलो. ठीक है? Cool. Yeah. Thank you. 10 power minus 10 नहीं होगा पूनम, it will be 10 power minus 5, right? इसका आधा हो जाएगा. 3.4 root will be 1.7, I think. कैलकुलेटर में देख ही लेते हैं. 3.4 power 1 by 2. 3.4 root is going to be 1.84. ठीक है? So this is 1.84 if you want to know. S1 is going to be equal to 1.84 into 10 power minus 5. ठीक है? And otherwise होता है ये 1 into 10 power minus 5. तो there you go. मैंने solubility कम कर दी है because we are doing the simultaneous solubility thing. And S2 is going to be 2.4 times this. तो उसको निकाल सकते हैं हम यहाँ से. ठीक है? Cool. चलो. Now you can also do all this with an equation. अब आप लोग डर जाओगे. देखो ये आया ये दोनों. And same expression मैंने सेटअप किया है. ठीक है? Same चीज, nothing complicated. I've just written this down. Now I'm saying कि चलो. Now I have this expression. दोनों को ऐड कर लेते हैं. दोनों को ऐड करने पे ये मिल जाता है. How do I get this? देखो. This is S1 S2 plus S1 square. यहाँ पे S1 S2 plus S2 square. If you add both of these up, this is just like saying this is S1 plus S2 the whole square, which is S1 square plus S2 square plus 2 S1 S2. ठीक है? A plus B whole square का मैंने फॉर्मूला निकाला, which is 2AB A square plus B square plus 2AB. यही चीज हमने यहाँ पे लिखी है. Now from this you can also get this root ये सब आता है. यही चीज है दोस्तों. What I've done from first principles is the formula you get. Many questions if you search for solution online, it will give you this scary वाला root वाली चीज. वही चीज हमने की है. That's exactly what we did in this question. Yeah. Namaskar Rajat. Good evening Gary. How you doing? Okay. So that's my modus operandi to teach you the way and tell you, देखो, Ionic is easy. You don't need equations. You need to do things from first principles. जो हमने किया है. But कुछ students बोलते हैं भाई हमको equations चाहिए, हमको हजारों equations चाहिए. तो for them, here are the equations. Now, let's talk about the next part of this session. Oh, काफी भारी है ये session. I understand that. Solubility है, थोड़ी कॉम्प्लिकेटेड चीज, बट वील गेट थ्रू इट. वील टॉक अबाउट सेलेक्टिव प्रेसिपिटेशन नाउ. Simultaneous solubility का आइडिया था कि we put two things together and we'll see कि what is how it affects the solubility. कम हो जाता है because common effect. Selective precipitation was the other idea I was talking about. Yeah, I have two or more ions that have a tendency to precipitate with a counter ion. यार ये अंग्रेजी का मतलब क्या है? In this case, let's take AgCl and AgBr. Both of these can precipitate out if I add something else to it. What can I add to it? Let's see. देखते हैं. ठीक है. Let's say I'll add AgNO3 to it, right? ठीक है. तो इसको मैं अगर मेरे सोल्यूशन में Cl माइनस एंड Br माइनस आयॉन्स है, ठीक है, मैं ऐड कर रहा हूं AgNO3, then what will happen is what will get formed? AgCl and AgBr, and both of these will precipitate out. ठीक है. तो ये प्रेसिपिटेट किस कॉन्सेंट्रेशन पे करेंगे? दैट इज व्हाट वी वांट टू फाइंड आउट. ओके, जो सबसे कम कॉन्सेंट्रेशन का वो सबसे पहले प्रेसिपिटेट आउट करेगा. दैट्स व्हाट दिस इज सेइंग. लोअर कॉन्सेंट्रेशन ऑफ आयंस ऑफ द रिएजेंट फॉर प्रेसिपिटेशन विल फॉर्म प्रेसिपिटेट फर्स्ट. अगर ये अंग्रेजी थोड़ी मुश्किल लग रही है, डोंट वरी, विल डू अ क्विक क्वेश्चन, विल फिगर इट आउट. देखो, सो इनिशियली दिस इज अ क्वेश्चन फॉर यू व्हिच विल सॉल्व टुगेदर. गुड इवनिंग लावण्या, हाउ यू डूइंग? बढ़िया, आई एम ग्रेट. हाउ आर यू? गुड टू सी यू हियर. यू हैव कम इन एट द राइट टाइम. इससे पहले तो चीजें इंटरेस्टिंग थी, बट नाउ थिंग्स आर गोइंग टू गेट pretty intense in a fun way. It's okay, Lavanya, don't worry about it. You can check out the पहले वाली चीजें बाद में, what we covered. Okay, so I have Cl minus ions, bromide ions and iodide ions, all of them to be this concentration in a solution. और इन सबकी Ksp values are known to us. Okay, जो दी हुई है. AgNO3 I'm adding gradually. Now when I do this, which one will precipitate out first? ये वाला थोड़ा आसान है करना. थोड़ा आसान इसीलिए है क्योंकि देखो, it is very clear that this will precipitate out first क्योंकि इसका Ksp सबसे कम है. And this is just like that formula. You remember we said S into 0.1 equal to Ksp? That's all we are going to do in this case also. Because it would be technically S into S plus 0.1, but since S is much smaller than 0.1, अरे ये क्या हो रहा है? S is much smaller than 0.1, हम लोग इग्नोर कर सकते हैं. We've just done that a minute back. AgI, Ayush, absolutely right. Good job. Right, पहले करेगा. Now the next question, furthering what Ayush is saying, देखो, is that what is the concentration of these ions? Okay, when this happens, concentration of the other ions when this happens. So पहले निकलेगा AgI, then AgBr, and then AgCl, and then Ag plus required for concentration for precipitation of AgI. Look at it. Look at how small it is. So you need just 10 power minus 16 molar. Now, if you're going to ask me, where is this useful? It's a very interesting question. So you've heard of all of these airports पे checks होते हैं, right? When they check for materials that could have explosives in them. So what happens is कि an explosive is a basically a chemical reaction, right? So बहुत ही कम concentrations of volatile elements are there or volatile compounds are there. और उसका बहुत trace elements फिगर आउट करने के लिए, उसका बहुत ही कम क्वांटिटी में वॉलेटाइल सब्सटेंस, उसको जो है डिटेक्ट करने के लिए यू यूज दीज आइडियाज. आई एम नॉट मेसिंग विद यू, दिस इज सीरियस. वेरी कूल एप्लीकेशन ऑफ दिस. श्योर, मे बी यू डोंट यूज AgI एंड ऑल ऑफ दैट, यू यूज समथिंग एल्स, यू यूज मे बी समथिंग एल्स दैट चेंजेस इट्स पाई बॉन्ड स्ट्रक्चर, उसकी वजह से कुछ इलेक्ट्रिसिटी निकलती है एंड दैट शो द डिफ्लेक्शन समथिंग. इफ दिस सीम्स अ लिटिल रैंडम टू यू, look at how bomb detection happens or explosive detection happens at airports. It's very fascinating. Okay, they use very high state of the art stuff, but the basic idea is the same. There is something that precipitates out and you're able to see something very quickly. Okay, anyway, cool. So पहले AgI निकला, AgBr के लिए कितना निकलेगा? You do the same thing. You divide it by 0.1, you get 10 power minus 12 to be the idea over here. What am I doing? ये कहाँ से equations आ रही है? I'm just saying that look, Ksp is going to be equal to the concentration of Br minus times the concentration of Ag plus, and this we have fixed as 0.1. तो हम लोग बोल रहे हैं कि this is going to be S. That's it. Okay, just to give you a quick recap of everything we've been doing. Lastly, you can say कि चलो AgCl पे क्या निकालेंगे, देखो ये. That's it. Okay, so next question, next part of this question, हम लोग, hey Arun, what's up? हम लोग theoretical mode में जा रहे हैं, yeah? When AgBr starts precipitating, उस समय Cl माइनस और I माइनस का कॉन्सेंट्रेशन क्या होगा? अब ये थोड़ा टेढ़ा सवाल है, थोड़ा मुश्किल लग रहा है, डोंट वरी, विल गेट इट। व्हेन AgBr starts precipitating, AgBr कब प्रेसिपिटेट हो रहा था? AgBr was precipitate जब ये था वैल्यू Ag प्लस की, ठीक है ना? देखते हैं कहां था, यस, AgBr starts precipitating out at 10 power minus 12 molar. Okay, at that point, what is the concentration of Cl minus and I minus? Interesting. Cl minus तो 0.1 ही रहेगा, because Cl minus is not precipitating. Cl minus तो अभी तक precipitate हुआ ही नहीं है. Remember, order is first I minus, starts precipitating, then Br minus, then Cl minus. ठीक है? Since we are at the middle place, which is Br minus, so Cl minus is not precipitated. So it remains as 0.1. Same as initial value. And then you figure out, अच्छा I minus का क्या होगा? Use that same expression. मैंने कुछ fancy नहीं किया है. KSP is I minus times Ag plus. And Ag plus कहां से आया? From AgBr. अरे G कहां से आ गया? From AgBr, which was 10 power minus 12. है ना? This is what we have substituted here. और KSP वैल्यू तो मैंने यहां दी हुई है, तो देखो अब निकल गया इतना. So this is the cool part. We have done three things. We figured out firstly कि I minus सबसे पहले precipitate करेगा. Secondly, we found out the exact concentration of Ag plus ions when I minus, Br minus and Cl minus precipitate out. We got three different values. The third thing we have done, this is the coolest thing, कि जब Br minus concentrate कर रहा है, precipitate कर रहा है, उस समय how much of I minus is in solution? I minus initially था 0.1, but वो precipitate करना शुरू कर गया 10 power minus कितने पे? 17 या something पे ना? Let's see कितने पे? It started precipitating at 10 power minus 16, right? But now the concentration is 10 power minus 12, right? कहाँ गया हमारा सवाल? Right here, right? So from Ag plus going from 10 power minus 16 to 10 power minus 12, I minus goes from 0.1 to this. That's it. That's it. Okay. That's the interesting part. So this is why we need these equations. Without these equations, you cannot calculate any of these things. Okay. क्योंकि it's not a linear scale कि यहां से ये हो जाएगा, वो हो जाएगा. Yeah. It's all has to do with KSP. ठीक है? Any doubts, guys? कोई doubts है तो पूछ लो. कोई doubts है तो please पूछ लो. Just थोड़ी सी चीजें ही बाकी हैं. This session I know is a little intense. Just 2-3 सवाल हैं, then we'll call it a day. ठीक है? Just 2 or 3 more questions. Cool. Okay. So what is the effect of pH on solubility? This is from NCERT itself. Solubility में, especially weak acids, phosphorus, phosphates, anything else, solubility की increase हो जाएगी if I add some H plus ions in it. मतलब कि weak base की solubility बढ़ जाएगी अगर मैंने POH बढ़ाया, यानी कि pH घटाया. pH घटाया नहीं, pH basically become very high. So low pH, which means high H plus ion concentration पे phosphate या फिर other weak acids की solubility बढ़ती है. क्यों? Look at this. क्योंकि the anion concentration, it reacts with H plus and forms HA. That's what it's saying. Anion due to protonation, तो solubility की बढ़ जाती है. So what is happening is कि I have got some, something like this. Say AgA, and this gives me Ag plus and A minus in solution. और जैसे ही A minus बन रहा है, that A minus reacts with H plus and forms HA. So look, this is pushing the reaction in the forward direction. This is the exact opposite of common ion effect. It may seem like कि मैं कुछ common ion add कर रहा हूँ, but I am not doing that. I am not adding a common ion. I am adding something that removes this ion from solution. ठीक है? So don't get played by this expression कि लग रहा है कि अच्छा ये है दोनों ions ये common है. No, this leads to this. Okay, which means कि all the A minus that reacts comes from here. Okay, so all of this comes from 1. Okay, let's see a question to understand this. The ionization constant of benzoic acid is some value. KSP silver benzoate is some value. How many times is silver benzoate more soluble in a buffer of pH 3.9 compared to solubility in pure water? ये सवाल directly NCERT से, and I'm so proud to say this out loud because NCERT is beautiful and this is proof of that. Chalo, let's go ahead and solve this directly. If you want, you can also try solving it with me, but my goal is to teach you. Okay, पहला केस लेते हैं, straightforward, no buffer. When there is no buffer, things are doable. AgA हम लोग सेटअप करो, Ag plus A minus. A मतलब ये ना, देखो दिस इज अ वीक एसिड, तो मैंने लिखा है Ha. A minus is the benzoate part of it. ठीक है, कूल. KSP हो गया ये, S वैल्यू हो गई ये. ठीक है, कूल. दिस वाज स्ट्रेट फॉरवर्ड. नाउ व्हेन आई ऐड द बफर, तब क्या होता है? मैंने जस्ट अभी आपको बताया था क्या होता है. जो Ag प्लस था, इट इज गिविंग मी Ag प्लस एंड A माइनस, एंड दिस सेम A माइनस इज रिएक्टिंग विथ दिस H प्लस, जिसका बफर था, pH था, ये वैल्यू, राइट, एंड इट्स फॉर्मिंग HA. लुक एट दिस. हमने बहुत शुरुआत में, व्हेन वी डिड द केमिकल इक्विलिब्रियम आइडियाज, वी वर टॉकिंग अबाउट रिवर्सिंग अ रिएक्शन, इनवर्ट्स द K वैल्यू. दैट इज व्हाई मैंने लिखा है 1 by Ka. क्यों? क्योंकि HA giving you H plus plus A minus, right? This expression will give you Ka, which is H plus times A minus divided by HA, right? So this is 1 by K. Look at this. इन दोनों equations को add करो and you get this beautiful thing which looks a lot like hydrolysis, right? This looks like hydrolysis in a way, right? कि A minus ion है, पानी के साथ react कर रहा है, but in this case it's not reacting with water, it's reacting with the H plus ions over here itself. ठीक है, this is as complicated as it gets in solubility. Now once I do that, then KSP by Ka is going to be the new K for this one. कोई doubts है? Any doubts? So now देखो, I started off with this, इसका solubility है S, यानी कि अगर ये react कर जाएगा, I've got this, this and this. ठीक है, H plus ion concentration is, you take the idea to be much higher than that of the solubility itself. ठीक है, so I am assuming that this is equal to H plus itself. If it is not, you'll get a quadratic equation. So I get this beautiful expression over here, which is very, very new. ये हमने अभी तक कहीं देखा नहीं, but that's okay. From math we have proved this, right? With buffer, remember buffer वाला क्या idea है? हमने बस ये लिया है कि acid gives you H plus plus A minus, and then K हम लोग setup किए, and you get this, right? Nothing new here. The only thing is कि I can say that this thing, ये concentration of salt by acid, which happens to be equal to this, is this value. इसमें you will have to use a calculator or a log table to get that. भाई, this is simply going to be equal to 10. ये NCERT का ही सवाल है, इसलिए मैंने as it is use किया है. I haven't changed anything. This is a question from NCERT. ठीक है, खैर, I get that this is equal to 10. Okay. कुछ तो यहाँ पे similar लग रहा है. देखो ये H plus by Ka was also there over here, right? This here, it says S square is going to be equal to KSP into 10, which is the same as H plus by Ka. ठीक है, this is this right here, I've substituted. So you get that the solubility has increased root 10 times whatever that value is, 3.3 something, right? 3.32 या जो भी है. That's the answer to this. विशाल 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 विशाल, बहुत विशाल काम किया आपने. Good job. Intense, very intense. Good job, Lavanya. I saved the best for the last, right? Solubility. I decided कि एक पूरा सेशन सिर्फ solubility करना बहुत जरूरी है, क्योंकि इसमें इस टाइप के सवाल है. How you feeling? All good? सब लोग ठीक हैं? Yeah? Shall we do a couple of more questions? How you feeling? चलो एक सवाल करते हैं. कहाँ का सवाल किया जाए? Let's do a question from NEET 2014. बहुत इंटरेस्टिंग सवाल है. Use the Gibbs energy change for the following reaction. That's okay, Vishal. Yeah, Lavanya. Good job. You're right. Absolutely right. 3.32. Yeah. Using the Gibbs energy change, delta G is equal to this huge value for the following reaction. Matlab, this is a non-spontaneous reaction. Okay. Calculate KSP of this in water. How do you do this one? How do you do this? Arun, good job. इस सवाल को कैसे किया जाए? This question is interesting. Delta G naught is positive. Well, look, equilibrium में delta G is equal to 0. I'll give you guys a starting point. I'll give you a starting point. That's all right. Good, Lavanya. That's good. Agar equilibrium is the starting point where delta G is equal to 0, then you get this. Okay? Kaise? Because remember, delta G naught plus RT ln Q, or ln basically Q, is going to be equal to delta G. Now you say delta G equal to 0, which means, reaction is at equilibrium. At that point, you get this whole thing, expression to be 0, and you take that to the other side. K is equal to KSP. That's all I've done. अरे वाह, इतनी जल्दी जवाब भी दे रहे हैं आप लोग. बढ़िया. सवाल शायद कर चुके हैं, but anyway, good job, विशाल and Arun. Excellent stuff. ठीक है, we'll solve it then. इसको मैंने थोड़ा सा स्कैम किया. I have not taken this value of R because look at this. I just need to figure out कि 10 power उसकी वैल्यू क्या है ना, my answer is done. So I can take a few shortcuts, right? I can write R as this. I can take temperature to be 300. I can write R as this. हम लोग सब ये सब shortcuts ले सकते हैं. And if you do all of this, you get that log KSP is approximately equal to 11 and KSP is approximately equal to 10 power minus 11. उसका सबसे closest answer is B. Good job. बन गया. Beautiful. Great job, Lavanya. Absolutely great, Lavanya. Arun, Vishal. सही है. एक लास्ट सवाल कर लेते हैं. काफी इंटेंस सेशन हो गया. एक और सवाल कर लेते हैं. Then we'll call it a day. Right? And that we'll be done with the whole of equilibrium. काफी बड़ा chapter, हाँ. चलो, ये वाला सवाल. ये वाला डायरेक्ट है. Yeah, exactly, Vishal. In a question like this, बहुत simple है. What is the minimum pH at which MgOH whole twice starts precipitating from a solution containing 0.02 molar MgCl2? और KSP वैल्यू दी है MgOH whole twice की. Now, ये वाला काफी सिमिलर लग रहा है. हाँ, we did that BaOH whole twice pH 12. इसका उल्टा है. This is the opposite of that. But the expressions are similar, right? In this case, also, well, चलो मैं ज्ञान नहीं था. I'll wait for you to do it. Try करो, इसको try करो आप लोग. In this case, approximate वाला idea चलेगा? Let's see. Do you think? I don't think जरूरत है उसकी. Vice versa. Exactly, उसका उल्टा है. Absolutely right, Ravanya. Yeah, 100%. Vishal is saying B. चलो. Be careful, Vishal. I know what you did. मैंने भी यही किया था शुरुआत में, but ध्यान से करने वाला सवाल है. देखो, I'll help you guys a bit. MgCl2 gives me Mg2 plus and Cl2Cl minus ions, right? This is a salt that just goes all the way. So this means कि I've got this, but I don't care about this so much. But I've got this in solution. मतलब ये fix हो गया, ये हमको नहीं मालूम है. We don't know OH minus ion concentration. Sure, I know यहाँ पे aqueous होना चाहिए. I should write that, but in this, interest of time, वो हमने skip कर दिया था. KSP is simply going to be equal to this 0.02 times OH minus ion square, right? So KSP divided by 2 to 10 power minus 2 will be equal to OH minus whole square. So from this, you get POH to be 5 minus log 9 divided by 2. Don't forget the by 2. है ना? 9.04 आ रहा है. अच्छा. Very interesting. Hey, एक minute. You're getting 9.04? मुझे कैलकुलेटर निकालना पड़ेगा. What do you guys do? एक बार ट्राई करो. या हमने कुछ गड़बड़ी की तो बता दो. मेरा तो कुछ और आ रहा है. Log 9 is 3 log 3. Log 3 is 0.3. है ना? 0.5 actually. हाँ, दाल में कुछ काला है, कुछ इंटरेस्टिंग हो रहा है यहाँ पे. 9 plus log 9 by divided by 2 क्या आता है? अरे यार, मेरा तो 9.477 आ रहा है. Look at this, है ना? खैर मैंने चेक किया था, बट सिंस आप लोग दोनों लोग बी बोल रहे हो, तो आई थॉट आई जस्ट चेक. आई थिंक इट शुड बी सी. You see what I did, right? No pun intended. OH minus ion whole square will be equal to this expression right here, which means कि equal to 9 to 10 power minus 10. फिर मैंने negative log दोनों तरफ ले लिया, तो 9 this divided by 2, right? 10 power minus 10, 10 by 2 मतलब हो गया 5 minus log 9 by 2, correct? फिर pH हो गया 14 minus POH. Let me write that, अगर वो लग रहा है मैंने step skip किए. 14 minus POH. यही हमने यहाँ पे यूज करके सेकेंड वाला चीज लिखी है ना? C correct है. Okay, cool. Lavanya and Vishal, good job. Lavanya, excellent, you figured it out. This should be the right answer. Whew. Bhari session, I know. Time wise, so we seem like we've pulled in within time, but I know, काफी भारी session. Khair, thank you so much for sticking around. It's been awesome as always. I'll meet you guys at in some time. Yeah, 8:30 बजे मिलते हैं for the next session. Yeah, options काफी close थे. I know I've been increasing the difficulty in the last couple of sessions, and that's mainly because I want you to be ready. Yeah, and want you to be not scared of ionic equilibrium ever again. चलो, and chemical दोनों खत्म हो गया. Please NCERT solve करिए. I'll see you at 8:30 for DNF block. Straightforward chapter है. We'll get started on that. All right, चलो. With that, equilibrium is done. NCERT करना मत भूलना. Yeah. Bye bye.